All right, welcome back. This is our final unit for our final lesson for Unit 5 on matrices. And this one's going to be involving using Cramer's rule to solve a system. And I'm going to start with this two-variable system. And I've already kind of set this up, and I just want to talk about what I did. So it's a two-variable system, and the first thing I created was a matrix that I'm going to call D. And it is the coefficient matrix. So we have 1, 4, 2, 7, right? These are in standard form, so I've got 1, 4, 2, 7. And now I'm going to create a new matrix. It's still a 2 by 2 matrix, but I'm calling it D sub X. And the other one over here is D sub Y. And what I want you to do is, if you look here at the coefficients of X, they were 1 and 2, right? That's what these 1 and 2 were. In this matrix, I've replaced those two coefficients with the constant. I've replaced the X coefficients with the constants from those two equations. So first constant, second constant. The second thing I did here, D sub Y, is a matrix made up. Now this time, the Y coefficients have been replaced with the constants. So I replaced the constants here where they were the coefficients of X, and I replaced the constants here where there was the coefficients of Y. And you can see I left the Y coefficients in this first D sub X, and then over here I left the X coefficients for D sub Y. So when I'm calling it this, what I'm doing is saying I'm swapping out those numbers where X's were. So they aren't the coefficients of X anymore, they're the constants. They're not the coefficients of Y anymore, they're the constants. And what I'm going to do is find the determinant of each of these. So what's the determinant of this guy? So I'm going to change my notation. And then here, last one, finally, 1, 2, 7, 12. All right. So remember, if it's a 2 by 2, finding the determinant of these guys is the easy thing. So 1 times 7 minus 2 times 4. So we've got 7 minus 8, or negative 1. For this guy, we've got 7 times 7 minus 12 times 4. So we've got 49 minus 48. That's positive 1. And finally, for this guy, we've got 1 times 12 minus 2 times 7, 12 minus 14, negative 2. So these numbers are going to be important. So what Cramer discovered, and again, this happened back in the mid-1700s. So he did this without the technology that we have now. So when we talk about using Cramer's rule on a 3-variable system in a second, it's kind of cool and amazing that he was able to figure this stuff out. So to solve the system, right, if we're solving the system and it's 2 variables, our solution is going to be some coordinate. So I want to know what X is, and I want to know what Y is. So Cramer found out to solve for X, you take the determinant of this guy, and you divide it by the determinant of the coefficient matrix. And you do the same thing to find what the value of Y is. It's the determinant of this guy divided by the determinant of the coefficient matrix. So since I already found those answers, I can easily solve for X. So it's the answer I got for the determinant of this matrix, so it's 1 divided by the determinant of the coefficient matrix, negative 1, which means I now know what X is equal to. It's equal to negative 1. Oops, running out of room. I can do the same thing for the solution to Y. I'm going to use this negative 2 because it's the determinant that I found here, divided by the coefficient matrix determinant. So we see Y is equal to positive 2. So the solution to this system is negative 1, positive 2. Now we could verify that using lots of different methods, many of the ones that we've talked about before, so you can go back to how you know to solve a system of equations. We can use substitution, and we can verify that this is true. The easiest way, I think, to check is to utilize a graph. So if we were to graph this, so remember, and this is a nice little review, to graph, we need them in slope-intercept form. So I would need to solve both of these for Y. So we have 4y equals negative x plus 7, and then I would divide by 4. So 1/4 x plus 7/4. So that's the first equation I would plot. This one I'm solving for y, so 7y equals negative 2x plus 12. So y equals negative 2/7 x plus 12/7. So I'm just going to leave them as fractions because why not? All right, so I'm going to go ahead and graph these. I have the light on because it's about to rain. So negative 1/4 x plus 7/4, negative 2/7 x plus 12/7. Make sure my window's set nicely. And kind of hard to see, right? It looks almost like these are the same line. But we can solve when they were plotting there that they were in fact not the same. So I'm interested to see where they intersect. So I'm using that function of my calculator. So just first curve, make sure it's the first one we entered. Second curve, make sure it's the second one. Hit enter. You can make a guess if you want to, but remember we talked about that. And it gives us the answer of -1, +2. So this is using Cramer's rule on a 2-variable system. So now we're going to try it with a 3-variable system. And if you watched the last video, you saw that kind of the hardest part about finding determinants was whenever we increase the size of our matrix. So if it's a 3x3 or a 4x4, we were able to see how those steps to find the determinant get a little crazy and you can get a little confusing or bogged down. So I'm going to utilize my calculator because it is important that you guys know how to use your calculators to solve this system. But again, I'm solving this system. I'm going to use Cramer's rule. All right. So here's how to do it with a 3-variable system. And for this specific problem, we wouldn't be able to use our graphing calculator because our graphing calculators only graph in 2D, not in 3D, so not in 3 variables. All right. So now we need to solve for x, we need to solve for y, and we need to solve for z. Right? So I'm going to go ahead and I'm going to do this one. I'm just going to set up the notation backwards from what we did last time. So to get x, it's the determinant of an x matrix that we're going to build divided by the coefficient, the determinant of the coefficient matrix. Same thing. So these are no different. The only difference is now we're going to create one of these for z, and we're going to divide by the determinant of the coefficient matrix. So here I need to find g. I need to find x. I need to find y. And I need to find z. All right, so first let's find the coefficient matrix. That's the easy one. Just verify that these are in standard form. So x, y, z, x, y, z, x, y, z, we're good to go. So the first one is 2, 2, -3, 1, -4, +1, 4, -1, 2. All right, that's the easy part. Notice we didn't use -26 and -1. So if we were augmenting this and using the Gauss method, we would go through that, Gauss-Jordan elimination, but we don't have to do it this time because we're creating a new way. We're using Cramer's rule. All right, so if I go back, 2, 1, and 4. 2, 1, and 4 were the coefficients of x. I'm building a new matrix here where instead of using the coefficients of x, or this column, I'm replacing that column with the coefficients. So -20, 6, and -1. But that's the only thing that's changing. The other stuff remains the same. Okay? So I'm going to do the same thing for the y. So now, where my y coefficients in this coefficient matrix were 2, -4, -1, I'm replacing the y column with the constant. So now the y column, 2 becomes -20, -4 becomes 6, and -1 Oh, -1 stays -1, but only because they're the same. So now the x stays the same, and the z column stays the same. So finally, I need to build this one for z. So now, instead of using -3, 1, and 2, I'm going to replace that with -20, 6, and -1. So now x and y, those two columns, stay the same. And now I just need to know what these are equal to. Because once I find the determinant of these, I'm going to use them up here in these equations. So this is where I'm saying using your calculator is going to be your friend, because you would have to find the determinant of 4 3x3 matrices. And again, they take quite a bit of time, and I understand that, and as long as you understand the steps to do it, I'm okay with using your calculator, but try some on your own before you do that. All right, so I'm going to get rid of that graph, and I'm going to go ahead and call up a matrix, and I'm going to edit the matrix. So I need these to be 3x3s. So 2, 2, -3. 1, -4, 1, 4, -1, and 2. All right, so now it's kind of up to you. Do you want to go find the determinant of this matrix, or do you want to put all of the matrices in? So it's, dealer's choice here. So I'm going to go ahead and find the determinant of this matrix. So I'm going to go to matrix, my matrix menu. I'm going to go to math, determinant, and then I'm going to go back and say I just put that in as matrix 1. So this guy, I closed my pen for some reason, -55. So everywhere, all of these denominators are going to be -55. So x is divided by -55. Y is divided by -55, and Z is divided by -55. So now I just need my numerators, right? So to find my numerators, I'm going to go back in, and I'm going to put a new matrix in. I can use this 3x3, and this one, I'm just going to go and type in -20, and then 6, keeping everything else the same, and then -1. Okay, so here's my new matrix. This light is helpful only sometimes. Other times, super annoying. All right, so now go back. So the determinant of that guy that we just typed in, so this one right here is 144. So see where he's used? Right here, 144. And of course we could simplify. So now I'm going to go in and do the y's. Let's do that. I'm just going to use a 3x3. So 2, -20, I don't need to change that. 1, 6, don't need to change that. 4, -1, and 2. All right. 61. Easy peasy. So this one is 61. Is that the one I just did? Or did I do this one? I think I did this one. I'm really losing my mind, y'all. Okay, yeah, I did this one. So now we need Z. Okay. So 2, 2, -20. Okay, 1, -4, 6. 4, -1, -1. All right, last but not least. So this is -230. So now y, remember, was the determinant of the y matrix that we created. So 61 goes here, and then z, right? -230 goes here. That was the chair. It wasn't me. All right, so we can see what x is equal to. We can simplify this if you want to. If it can be, remember, we should simplify them. So this one, you can make it a decimal. It's -144/55. Y, it cannot be simplified. -61/55. This one can be simplified. They're both negative also, so 46/11. So these three lines in 3 dimensions would intersect at -144/55. 5 and 46 over 11. And there is our solution. So again, we can prove that we were right by using that Gaussian elimination that we learned. And you could use, can't use your calculator. Yeah, so I don't know. I think that this way is a lot easier to solve. You can also use a matrix equation if you wanted to, but I think using Cramer's rule is one of the easiest ways to solve a system of equations, especially if you have access to a calculator. So if we didn't have access to a calculator, then obviously we would have to do some Gaussian elimination. But other than that, Cramer's rule is probably the easiest way to do it. All right, so that wraps up Unit 5 for us. So a few of you guys have been asking about grades and why they're being exempt in the grade book. So again, it has to improve your grade in the class in order for me to put it in. So if it's not going to do that, then I have to exempt you from it. So I can't pick and choose what assignments you do and get good grades on to put in, but I do have some plans on ways that you can improve your grades. So I just ask that you are learning. I'm keeping track of your synergy, and if there's something that you can do, if you're sitting at like an 88 or a 78 or one of those grades where you're so close, then we'll talk about ways to move your grade up. But really, I will be working with students who have been working with me this entire time. So if you've been skipping assignments or have just completely checked out, then I hope you would understand that you're not going to be given the same opportunities that someone who has been busting their butt this entire time will be given. So you have to be keeping up with your assignments to get these little special treatments, right? So I miss every single one of you. If you need additional tutoring or opportunities to meet with me on Zoom, we can do private tutoring sessions. I just did one with two classmates today. So you can bring someone else if it's, it's scary, I don't want to go by myself. So whatever you're into, whatever you need, just send me a message on Reminder in my email, and I will set something up. Okay, bye!